We're continuing our discussion of the lossless transmission line model. And as we saw last time, we have this, if you like, it's like a ladder network of C's across and these elements, these inductive elements. And we're going to telescope in to look at this segment. So it has an inductive element on each side of the capacitor, and blown up, you see it here. So we see that we made it symmetrical. So L is going to be the line inductance, the transmission line inductance per unit length. So multiplied by a little element of length. So this is inductance, and the half just makes it symmetrical. We could have equally well put it all on one side. So that is the delay part that we talked about before. And the shunt part, the storage of current that's going to be charging and discharging, if you like, comes from here. And that's the same idea, capacitance per unit length times a bit of length. So this is the capacitance part. Now, this is our piece of line. What actually happens? Sam, can you take us through what this is actually going to do before we analyze the equations and circuit in detail?
Sure. Well, first you see some kind of current coming into the line, and there's a split here. So I would assume you have some current going down here. Let's call it IC because I of capacitor. And you have some change in current, so I plus delta I.
So we either have a loss or gain in current as we go through this section. Now what about the voltage drops here?
So, well, there is a voltage drop across the inductors, right? So let's just call it, didn't draw it too well, but V plus delta V.
So our job then really to analyze this in circuits, we know what the V is here and the I, we're given that starting, and then we go through this little T element and the current changes and the voltage changes over this small length of line. And you could, in fact, the length of line you could think of as delta Z, and this is half delta Z on each side of the dividing node where the capacitor is.
Yep.
But before we leave this telescope image, what will we do next?
What do we do next? Well, we have some kind of voltage, we have some sort of current. What was the favorite topic that students went through in second year?
Potassium chloride. No, I mean KCl.
KCl, KVL?
KVL.
So we will do KCl, KVL on this and see what happens.
Yeah, let's see if we can get an established way of seeing if we get a delay of the voltage moving down the lossless transmission line. Good work.
Thank you very much, Matt.